Okay, so this is what you should have filled out from your warm-up. Shouldn't be anything too crazy. Just kind of, glance and make sure your answers are correct. We're going to talk about this in a moment. I want it in terms of X, Y, and R. And remember the relationship if you need it. R is equal to the square root of X squared plus Y squared, and that's just from your Pythagorean theorem and that triangle that it makes. Reference triangle should be memorized, as is your table of value or your trig values for 30, 45, and 60. Sine is always the height, cosine is always the base. What I want to kind of talk about briefly is, let's see, sine of theta is y over r, cosine of theta is x over r, and then tangent of theta is y over x. R is always positive, and that we kind of talked about that the other day when we were going through and determining what R was. So this is a coordinate plane, and this is where our angles hang out. So what we're going to look at in this part is x is positive, y is positive, and the quadrants that happens in. So in this quadrant, x is positive and y is positive. So if I put a point, that means if I went over 2, my coordinate was 2, 3, I'd be in the first quadrant, x is positive, y is positive. That's what we're talking about when we're saying positives and negatives with my x's and my y's. This quadrant, second quadrant, did it again. You're going to have a negative x as we go to the left, so it'll be like over negative 2, but your y is positive. Third quadrant, you went negative x. You're going to go down negative y. Fourth quadrant, positive x, negative y. Now, r is positive, so that would be your hypotenuse in all of those reference triangles in every single situation. So r is always positive. Looking at your ratios, sine, cosine, and tangent, we're looking at our y's and our r's. In the first quadrant, sine is positive, cosine is positive, tangent is positive. They are all positive. Looking at y is positive, r is positive, x is positive, r is positive, y is positive, x is positive. The second quadrant, positive y, positive r, sine is positive. You have a negative x, positive r, so that means all of your cosine values need to be negative. You have a positive y, negative x, so all of your tangent values are negative. The only one that is positive in this quadrant is sine. Third quadrant, we're going to work through the same thing, so sine is negative, cosine is negative, tangent, because it's the ratio of sine and cosine, is positive. And the last quadrant, so we'll circle that guy. Let's see, sine is negative because y is negative, cosine is positive, and tangent is negative. So the only one that's positive is cosine. So this is going to help us a little bit with our stuff today. All the trig ratios are positive in the first quadrant. Only sine is in the second quadrant. Only tangent is in the third quadrant. In the fourth quadrant, only cosine is. The way that we kind of remember this, it's acronym. All students take calculus. And that helps us remember, oh yeah, I know that sine is positive here. We're going to do some stuff today. We have to make sure, oh, I'm in the third quadrant. I have to make sure that tangent's the only positive one. Sine and cosine need to be negative. This is your first example in your notes. It says, find the 6 trig ratios of 315 degrees. We're going to do this without a calculator, and we're going to do it with a little sketch. So first step, we're going to sketch our theta. And 315 degrees, unit circle, hopefully you're memorizing that, should be about right here. So that's my 315 degrees, that is my theta. From here, look at our reference angle, and that's that guy right there. So my theta prime is hanging out down here. Now I need to know that reference angle, and that is a 45-degree reference angle. So when I do all of my trig, my sine, my cosine, and my tangent, I'm really just going to be looking at the fact that it's a 45-degree angle. That's going to be my first step. So we're going to do sine, cosine, and tangent, and then you know their reciprocals, cosecant, secant, and cotangent. So sine of 45 degrees is radical 2 over 2, as is cosine, as is tangent. So I'm just filling this in from that 45-degree kind of reference chart we had at the beginning of our notes. Now the trick is, this is in the fourth quadrant. All students take calculus. That means cosine is the only one that can be positive. Sine's negative, tangent's negative, cotangent's negative, cosecant's negative. So that's how I fill in my positives and my negatives. I didn't even need to really sketch my reference triangle. You can if you want to and fill in your sides, but I think this is a much quicker, much nicer way to kind of look at it. Next one, 240 degrees. So you're going to start with the same thing. Drawing it, 240 should put you kind of over here, hanging out. So here he is. That's your angle, 240 degrees. Trig doesn't technically work for him, so we have to make that reference angle, and that's my theta prime. My theta prime this time is going to be 60 degrees. So we're going to do sine, cosine, tangent, cosecant, secant, cotangent. This is going to all be based off of a 60-degree angle, so you can look at your chart. You have it memorized, hopefully, but it's radical 3 over 2, 1/2, radical 3, and then put the corresponding reciprocals in. All students take, the only one that's positive is your tangent, so throw negatives in front of your sine, cosine, secant, and cosecant. And there's your chart. Good to go. 6 trig ratios of 150 degrees. So 150 degrees should put you in the second quadrant. It should be hanging out about right here. There is our theta. This would be our reference angle. This is our theta prime. Theta is equal to 150 degrees. That means this guy is equal to 30 degrees. So we're going to fill out our chart based on 30 degrees. And then we'll add our positives and our negatives based on our quadrant. So this should be 1/2, radical 3 over 2, radical 3 over 3, and then the corresponding reciprocals. All students, the only one that is positive is sine and the corresponding reciprocal cosecant. Throw negatives in front of cosine, tangent, secant, and cotangent. You're good to go. The last example, and this should be easy breezy because you're not doing all 6, thank goodness, finally. We're going to do this without a calculator. The only one I'm worried about is sine of 135. So go ahead and get 135 out there. This is your actual angle. We use our reference angle to kind of use those trig values. So my reference angle is 45 degrees. So we're doing sine of 45 degrees, which is radical 2 over 2. All students, sine is the only positive one. There we are. Cosine of 330. So let's see here. 330 should put me about right here. My reference angle hanging out in there, theta prime. There's theta. So theta prime is going to be 30 degrees. So we're thinking about cosine of 30 degrees, which is, oh, I have to think for a second, radical 3 over 2. This is all students take calculus, so this is going to stay positive because of the quadrant that it's in. The last one I might need a little bit more room. So this is tangent of 120 degrees. Go ahead and sketch that out. 120 should put you right here. So this is your theta. Theta prime, your reference angle. So theta prime this time is 60 degrees. So we're doing tangent of 60 is what we're really thinking of, which is radical 3. All students, the only one that's positive, this is sine, so I need to make sure they say negative radical 3. So all students take calculus. It's going to save your butt with some of this stuff. But really, if you know your trig chart, and you have that memorized, and you know all students take calculus, this is a really nice assignment. So make sure that you take out or do assignment 4-6, and life should be good.